We're going to talk about proving triangles congruent now. There are 5 different ways of proving triangles are congruent. The first 2 we're going to talk about are what we call SSS and SAS. So SSS is going to stand for side, side, side. All this means is that all 3 sides are congruent. That's simple. So if you notice over here in this diagram, we've got these statements here, these congruency statements. It's stating that segment AB is congruent to segment DE. So we look over here and we see that AB right here and DE are congruent. Next one we have here is that segment BC and segment EF. We see over here we have 2 tick marks on BC and EF, telling us that those 2 sides are congruent. Okay, so we had an additional congruent sides. We had to add an additional tick mark here. The last one here says segment AC is congruent to segment DF. So here we see 3 tick marks and 3 tick marks. So since all 3 corresponding sides are congruent, we do have congruent triangles. So then we have our triangle congruency statement. Here's your symbol for triangle. Okay, so this is triangle, not the angle, which we'll see later on, but in these notes, but triangle ABC is congruent to triangle DEF by SSS. And that's how you can answer these. You don't have to write out side, side, side. You just use your letters, your abbreviations. So let's take a look at what we have down here. There's going to be a couple different ways you can tell. One is exactly with the problem right here, where you're going to have tick marks. We're seeing here I got one tick mark on a pair, on each triangle, so that tells us these 2 sides are congruent. I'm seeing 2 tick marks here. Do I have a matching? Yep, I got 2 tick marks here. And we got to look for that third. Over here in this triangle, we've got 3 tick marks. We look over here, look, we have 3 tick marks. You have to make sure. Now, had this had 3 tick marks and this one had 4, they would not be congruent. Okay, we'd only have 2 sides. But because we have all 3 sides have a partner, have a corresponding part that's congruent, side, 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 yes, they are congruent. So let's take a look at the second one. I'm going to look over here. I'm just going to start with the smallest number, just easier. I've got a side that's 2 feet. When I look over here, I see another side that's 2 feet. So instead of tick marks, they may actually have number values, okay, measurements. Look back over here on the left one, I see 3 feet. I look over here on the right one, and I see 3 feet. Now whenever I head over here back to the left, I'm going to see 4 feet, but over here it's 6 feet. So because of these, just one pair of sides not being congruent, we cannot say that these triangles are congruent because they are not congruent. Okay? So the last one here, again, has the numbers. So here I see a 5 on segment CB, and over here I see a 5 on segment FE. And there's a reason I'm saying those letters in that order. You'll find out in a few different notes. Okay? So then we're going to look back over here on the right side. Sorry, this is the left. And I see a 7. I'm going to go back over here to the right. And, yep, I see a 7. So I've got segment BA and segment ED are going to be congruent. And the last one here I see, on this one I see a 9. I flip over to the right side. Oh, I've got a 9. So these would be, yes, congruent. So again, the first and the third one here, we see that they are congruent. You may have it with tick marks, as a congruency tick marks, or you may have it with actual measurements. So just keep an eye out for that, and then also keep an eye out for if we have not congruent. Now we need to talk about something called the reflexive side. Okay, the reflexive side, I have another term for it, but your reflexive side is a segment that is congruent to itself. This is going to be used whenever you have what's called overlapping polygons, or you can look at it as 2 that are connected together, sharing a side. So I want you guys to see this example. It says segment BD is congruent to segment DB. Same exact letters, because it is this segment right here. If you look above, you can see a triangle. If you look below, you can see a triangle. Okay? And this is a reflexive side because it is shared by both triangles. Okay? So I've always called this what I call a shared side. This is something that will not be given to you. You won't see a congruency tick mark. You won't see a measure value. Okay? You're going to have to automatically see this and mark it congruent. Okay? For example, example number 2 right here, we're being told that segment AC and segment AD are congruent. So we're going to go over here, always mark these. AC right here is congruent to AD, right here. The next statement they tell us is segment CB is congruent to segment BD. So let's go find it. Segment CB, right here. We're going to add an additional tick mark, even though I'm using different colors, doesn't matter. We have to, it's a second pair of congruent sides. Put 2, we have to add a second congruency tick mark. And then here, BD, these are going to be congruent. So we have 2 tick marks. Then that's all the information you say, okay, so is triangle ACB, right here, congruent to triangle ADB, right here? Well, according to what we see with what we drew, no, because we only have 2 sides, but this is where you have to see this shared side, all on your own. And then we can put 3 tick marks just across both of them. So now we have a side, side, side. And if you're my student, or one of my students, you're going to notice that I put like little on one of the 2 triangles. I'm like, okay, I marked a side congruent. Here I marked a side congruent. And then here is side congruent, so I can see my SSS. This will make a lot more sense when you learn the other ways of proving congruency. Okay? So here we can say, we'll go ahead and add in here that segment AB is congruent to segment AB itself. Okay? So let's remind ourselves here, you have to look for shared sides or the reflexive side. This is extremely important. Okay? You will not be told that they are congruent. You're going to have to see 2 triangles connected, sharing that side, and they have to connect all the way. Okay? If they don't connect from one side to the other, if that one cuts off a little bit, they have to be the exact same length. Okay? So here, to answer the question, are they congruent? Yes. And we'll put here by SSS. So the next thing, we're going to go ahead and see another problem that you're going to see in these congruency ones is they're going to give us a bit of information here. First, we're told that segment BC is congruent to segment EF. Always mark them. BC right here, congruent to EF right here. Then we have segment CD is congruent to segment FG. So CD right here, second pair congruent sides, second tick mark. FG right here. What they want to know is what other information do we have to prove that they are congruent by side, side, side. So they gave us some, but there's one other thing we have to. Okay, well here I have a side, here I have a side, I need a third side. It's a triangle, and there are only 3 sides. So the other bit of information that we need to know is that this last pair of sides are congruent. So we can say what we need to know is segment BD right here is congruent to segment BD, EG. Segment BD and segment EG are congruent. That's what we need to know so we can say, yes, they are congruent. Now, the next way of proving congruency we're going to talk about here in a second, but the first thing we need to talk about is what's called this included angle. This is very, very important, okay? When we have an angle formed by 2 adjacent sides of a polygon, it's going to be, we'll just go ahead and highlight, formed by 2 adjacent sides. Remember that adjacent means next to. Okay, you have to remember this, next to. Adjacent is like your next door neighbor, okay? So in the diagram here, we're seeing in triangle ABC, angle B, right here, is the included angle, right there, that included angle between segment AB and segment BC. So the 2 segments form, they come together to create that angle. That's what your included angle. It's included between the 2 sides. So that's what we come up with our next one, SAS. I want you to notice how the A is between the 2 S's. It says side, angle, side. So it's going to go side to angle to side. The A is between the 2 S's. The angle is between the 2 sides. So here, we're going to have 2 sides, and the included angle are congruent. So we look over here. We have segment AB right here, is congruent to segment DE. So here I see one tick mark and one tick mark. Then we're seeing that angle B right here is congruent to angle E. And then the last two here, segment BC, I see two tick marks, is congruent to segment EF, where I see two tick marks. So we have congruent by SAS. A is between the two S's. That angle is between the two congruent sides. And when you write the letters like I do, that's why I like to do this, I can see that these actually literally go SAS. There's another way that you might see one A and two S's. And if you think in your head what that spells, it's no word. So it's a no way of proving congruencies. So if that angle was at A or C, it would not work because you would have a bad word spelled. You'd have ASS. Okay, so be careful with that. That angle has to be between the two. The only way you can have two S's and an A is if the A is between the two S's, angle between the two sides. Okay, so let's take a look at these. First, I see a tick mark here and a tick mark here. So I have a side. Angle C right here is right next to our segment BC, right? Angle Z is right next to segment YZ, so far so good. Then we take a look at our last side that they show us that's congruent, and I'm going to see that if I spell out those letters, that angle is between the two S's. It rounds the corner, SAS. That A is between the two S's. The angle is between the two sides. So yes, we are congruent. The middle one here, I see a side and a side. So we've got an S. And I only mark the S's and A's on one triangle, not both of them, okay? And I see an angle here and an angle here. So we've got A. And then the last one, I see another side right here and another side right here. So I've got another S. Now, we need to make sure that one triangle is an SAS and the other one is ASS. So you need to make sure that both of them do have the angle marked congruent between the two sides. So here the angle is between the two sides. Here the angle is between the two sides. So the A is between the two S's. Yes, we are congruent. Okay? Next, I am seeing a side right here. Okay, so I've got a side. I see an angle right here. No other sides are marked congruent though. So we have to remember, very important, here we have shared sides. Okay, we have to see right here they share segment KJ. So we do, in fact, have another side. And we look at both of them. We're going to round the corner. Start at one side. We go side, angle, side without skipping a beat. Right around the corner. Here, side, angle, side. So we do have the angle between the two sides on both of them. So the A will be between the two S's. We do have SAS. The last one here, we're going to say, okay, we're going to determine if these are congruent or not. All right, easy enough. We got a side here and a side here. So we got a side. Cool. All right, I see another pair of congruent sides. So we have another side. I don't have any angles. Or do I? This is another thing you are going to have to see on your own. It will not be given to you. Some of you are already looking at it going, I see it. We do have a pair of congruent angles. I told my students, I said, doesn't matter. Vertical angles are staying with us. They're not leaving. So here, another thing, other than shared sides, you must look for vertical angles. Must look for vertical angles. Do not have an option on it. You have to see the vertical angles. They will not give it to you. Okay? So now that we have these vertical angles, since they're connected, I can just look at one and say, okay, the angle is between the two sides. So I have SAS. Double check the other one. Is the angle between the two sides? Yes. So here we do have congruent triangles. So to answer, are they determined they're congruent? Yes, they are by side, angle, side, SAS.